Network Interface Card. A network interface card, universally known as a NIC, is the physical hardware component that allows a computer to connect to a network. While almost every modern motherboard has a network port built directly into the rear I/O panel, a dedicated expansion NIC is often required for high-performance servers, specialized fiber optic connections, or when the original onboard port fails. The evolution of connectivity. A NIC acts as the translator between the computer's internal data bus and the electrical or optical signals that travel across network cables. For a hardware technician, it is important to distinguish between the two primary ways these cards connect. Ethernet NICs wired. These use the standard RJ45 port. For over a decade, Gigabit Ethernet, 1000 Mbps, was the industry standard. However, in modern environments, especially for those managing home labs or high-speed storage 10 gigabit, 10 GBE, or even 25 GBE cards are becoming the standard for moving massive amounts of data quickly. Wireless NICs, Wi-Fi. These cards allow a desktop to connect to a network without a physical cable. They typically feature one or more external antennas to improve signal reception. Modern cards support the Wi-Fi 6E or Wi-Fi 7 standards, which utilize the 6 GHz band to avoid the congestion found on older 2.4 GHz and 5 GHz frequencies. Professional form factors, copper versus fiber. In a standard office or home environment, most NICs use copper wiring, Cat5e or Cat6 cables. However, in data centers and high-end server environments, a technician will encounter specialized fiber optic NICs. SFP Plus Small Form Factor Pluggable. These cards do not have a built-in port in the traditional sense. Instead, they have an empty cage. The technician inserts a specific transceiver into the cage, depending on whether they are connecting via short-range copper, DAC, or long-range fiber optic cables. This flexibility makes them the Swiss Army knife of enterprise networking. Advanced features for the modern technician. A dedicated NIC does much more than just provide a physical plug. It offloads several critical tasks from the main CPU to improve overall system efficiency. 1. WakeOnLand WoL. This feature allows a technician to remotely wake up a computer from a completely powered-down state by sending a specific magic packet over the network. This is an essential tool for performing after-hours maintenance or updates on a fleet of office computers without having to physically walk to each desk. 2. MAC address identification. Every NIC has a unique, hard-coded 48-bit identifier known as the Media Access Control (MAC) address. This is essentially the physical serial number of the card on the network. A technician will often use this address to assign a static IP to a server or to whitelist specific devices on a secure corporate Wi-Fi network. 3. Offloading and teaming. High-end server NICs can perform TCP offloading, where the card handles the complex math of packaging network data so the CPU doesn't have to. Additionally, a technician can perform NIC teaming, where two physical network cards are bonded together to act as one. If one cable is accidentally unplugged, the other instantly takes over, ensuring the server never goes offline. Troubleshooting a failing NIC. If a user reports they have no internet, and you see that the link lights on the back of the computer are completely dark, the onboard NIC may have died, often due to an electrical surge through the Ethernet cable during a storm. Instead of replacing the entire motherboard, the fastest and most cost-effective fix is to simply install a new PCIe X1 NIC expansion card and disable the broken onboard controller in the BIOS.